Hello everybody. Today we're going to be tackling some questions from the annual national assessment from 2015. We're going to be looking at some questions and answering them step by step with explanation involved. Okay, so we look at the first question, question 2, okay? Question 2 asks us to calculate without using a calculator. We must show all calculation steps where needed. Okay, so the very first question is quite simple. It is an addition operation. So what we need to do here is we need to write these numbers one underneath the other so that we know what to add. So basically what I'm doing now is I'm writing these numbers to get the total. Okay, so firstly what we do is we write in this notion, okay, we write the first number plus the second number with each number right below each number. So by that I mean 4 and 6 are aligned, 8 and 0 are aligned, 8 and 2 are aligned, 3 and 2, 4 and 6, 6 and 4. So they are aligned with each other. They are in the same row. Okay, so what we do is we say 4 plus 6 is 10, sorry. And we carry over the 1, so then it will be 1 plus 9 plus 0 is 9. 8 plus 2 is 10. We write down the 0, we carry over the 1. 1 plus 3 is 4 plus 2 is 6. 4 plus 6 is 10. Once again, we carry the 1. We say 1 plus 6 is 7 plus 2 is 9. And then we write 1 plus 0 because inevitably that is a 0. 1 plus 0 would be 1. So our answer is 1906090. Okay, then when we look at the second question is a division question, and with division we know how to do long division. So this is a long division question. So we have 6517 divided by 31. Okay, so the first step in long division is to check for the factors. Okay, so does 31 go into 6? No. But does 31 go into 65? Yes. How many times? We write down 31. 31 times 2 would give us 62. So it would be 31, 62. And after 62 plus 31 would give me 93. So it's safe to say that 31 goes into 65 2 times. Okay, so what do? We write down 2 above there. We say 2 times 31 is 62. What do we from there? We subtract it. So we subtract to get, we write our zeros over here. We subtract to get 7. 1 minus 0, 1, 5 minus 2, 3, and that minus that is 0, to get 317. Okay, so then what do we do from there? So then what do we do from there? We check if 317. So then what do? We go to the next portion. We say, how many times does 31 go into 650? How many times does 31 go into 317? Sorry, my bad. So in order to get a number that is closest to 317, what do? We go down our multiples. So the fourth multiple of 31 would be 124, because we are adding 31 to that. And if we go further down, we can see that we'll have 155, 31 once again. We have 6, 8, 1, 31 again, 7, 8 plus 3 is 11, and we just add that 1 there. Okay, so then now we have 217. We just need to write down the multiples. So this is the first, second, third, fourth, fifth, sixth, seventh. Okay, we plus by 31 again to get 8, 4, 2. Okay, plus 31 one more time, 9, 7, 2. 31 again, to get 10 plus 1, 7 plus 3 is 10, plus 1 is 11, plus 1, 310. Okay, 310 we plus by 31, we get to see that it's 3, 4, 1. Okay, so then we can conclude that 31 goes into 317 up until 310. So then we have 7, 8, 9, and 10. Okay, that was pretty easy because 31 times 10 is easy. It is 310. So then we write 310 over here. Okay, how many times, which is 10, right? Because then 31 goes into 310 10 times. Okay, so then we say 317 minus 310 will give us 7. Okay, and therefore we can conclude that 31 goes into 6,517 210 times with the remainder of 7. Okay, I'm sorry, 31 goes into 6,517 7 times with the remainder 210. So it goes into 6,517 7 times. Okay, then we go to our next question. We are asked to multiply these two, so 315 times 2, 3, 6. Okay, 5 times 6 is 30. We put down the 0, we add the 3. Okay, so with multiplication, we first multiply this first number, then we multiply that one, then we multiply that one. Okay, so then what we need to do is we need to say 6 times 1. Okay, 6 times 1 is 6 plus 3 is 9. Okay, then 6 times 3 is 18. We put down 18. We take down a 0, and then we can start with this 3. Okay, we jot down the 0 because the 3 is in the second position. Okay, so therefore, because the 3 is in the second position, we need to put the 0 and then start at the second position. Okay, so then 3 times 5 is 15. Okay, we carry over the 1. 3 times 3 is 3 times 1 is 3 plus 1 is 4, and 3 times 3 is 9. Okay, and then we jot down the 2 zeros because we're starting with the very first position, and 2 is in the very first position. Therefore, we need to jot down the 2 zeros so that we can start at this column. So then it will be 2 times 5. So 2 times 5 is 10 plus 1. We carry over the 1. 2 times 1 is 2 plus 1 is 3. Okay, and 2 times 3 is 6. Okay, and what we do from here is we add all these values. So 0 plus 0 plus 0 is 0. Okay, 9 plus 5 is 14. We're just going to jot down the 4. We're going to carry over the 1. Okay, 8 plus 1 is 9, plus 4 is 13. We jot down the 1. 1 plus 9 is 10. 1 plus 1 is 2, plus 9 is 11, plus 3 is 14. And then we carry over the 1 to the 6, and we say 6 plus 1 is 7. And we get our answer, which is 74,340. Okay, so that was pretty simple. It was pretty straightforward, straight to the point. Okay, let's look at this question here. So we are asked 2 cubed times 1 to the 4. Okay, what you need to know about exponents when 1 is the base is that regardless of the number of the exponents, if 1 is the base, then your solution will always be 1, because 1 is multiplying itself to the number that is given in the exponent. So for example, with 1 to the power of 4, we'll be multiplying 1 to itself 4 times. So that will be 1 times 1 times 1 times 1, which will give us 1. So regardless of the number you have in your exponent, okay, if your base is 1, then your solution will always be 1 regardless. So you can have 1 to the power of infinity, you could have 1 to the power of pi, you could have 1 to the power of 2020. Your answer will always be 1. Okay, but that only works with positive ones. It's a different story when it comes to negative ones, because with negative ones, okay, the trick between with negative ones is if you have a negative 1 and your exponent is odd, okay, if your exponent is odd, then your answer will be negative 1. But if you have negative 1 as a base and your exponent is even, then you will just have 1 as your solution. So for example, if you had negative 1 to the power of 2015, your answer would be negative 1. But if you had negative 1 to the power of 2020, which is an even number, then your answer will be 1, because negative 1 times negative 1 is positive 1. Okay, so that's where the theory came from. Okay, so let's go back to this question. This question says 2 to the power of 3 times 1 to the power of 4. So immediately we can just say, okay, that is just times 1. So basically we are asked for 2 to the power of 3. But anything times 1 is itself anyway. So we can omit this section and we can easily just say, okay, it is basically 2 times 2 times 2. Okay, so then what do we do from there? We work within the first two twos. Okay, so within the first pair of twos. So 2 times 2 is 4. Okay, great, but we still left with this 2. 4 times 2 is 8, and that would give us our answer. Okay, so then we carry over, we look at a question that involves surds and involves exponents. Okay, so with regards to surds, it is the square root or the cube root or whatever. So for example, this one over here has an indivisible 2, okay, and this is a surd. It's a square root of 144. So once you've known your multiples very well, you will know that actually 12 times 12 is indeed 144. Otherwise, if you do not know your multiples, you will struggle when it comes to surds when you are not allowed to use a calculator. Okay, so with the square root of 144, we can easily say the square root of 144, we can put 144 in its simplest form, okay, and we have 6/2. Okay, so with regards to transforming a surd into an exponential form, okay, the following rule applies. So if you have a m n, okay, you can say a m over n. Okay, so that is exactly what we're gonna do here. We're gonna say 12 2 over 2 plus 6 squared. 2 over 2 is 1, so we can just say 12 plus 6 squared. What is 6 squared? 6 squared is 6 times 6. 12 plus 6 times 6. What is 6 times 6? We say 12 plus 36, okay, to give us 48. So our answer would be 48. Okay, the sixth question asks us between fractions, and we are meant to multiply the two fractions. So we have 3 over 5 and we have 7 over 6. The nice thing with multiplying fractions is that you do not need to look for the lowest common denominator. With multiplying fractions, you just straight out multiply your numerators and you multiply your denominators, and it is as simple as that. You do not need to look for your lowest common denominator. You do not need to look for, but you do need to look for your lowest common multiple. Okay, but if the numbers are not related in any sort, so if they are prime numbers or if there's a prime number involved, such as 5 is a prime number, so it does not have a lowest common denominator or a lowest common multiple with 6, because 5 is a prime number. Okay, so what we need to do here is we need to say 3 times 7, okay, 3 times 7 is indeed 21, and 5 times 6 is 30. Okay, and we look at the next example. The next example, we need to follow the rule of BODMAS. Okay, and BODMAS is brackets of division, multiplication, and addition, subtraction. Okay, so what do we tackle first? We tackle the brackets. Okay, so we have 100 minus 12 divided by, and we look at the brackets first. So what is 8 plus 4? 8 plus 4 is 12. Okay, so we have 12. Okay, once we're done with that, we take, okay, brackets of division. We look at division. Division is 12 divided by 12. So we say 100 minus 1. Okay? And we get the answer that our answer is 99. Okay? So then when we look further, we can see that these sums are not really hard sums. They're just a continuation of the rules that we have been taught, and how to tackle them by consuming all of those rules that we have been taught previously. Okay, so then we look at the next section. The next section says write 1,6 as an improper fraction in the simplest form. Okay, so when it comes to questions such as these, we need to think of, okay, we have 1,6, okay? How can 1,6 be written as an improper fraction? Okay, improper fractions is when the numerator is larger than the denominator. Okay, so we have 1.6. This can easily be written as 16 over 10, okay? Because then 16 over 10, 16 goes into 10 once, and the remainder is 6, so it's going to be 1,6. Okay, so that is how we tackle it. That to write it in its simplest form, we know that the lowest common factor over here is 2. So what are we going to do? We're going to divide it by 2 to give us 8 over 5. Okay. And then we look at 2.3. 2.3 says a group of 25 grade 7 learners watched a soccer match. The ratio of the number of boys to the number of girls was 2 to 3. Sorry, that is not 2 to the 30. It's 2 to 3. How many boys were there? So the total number is, we just need to write down the essentials. So the total number was 25, okay? And the ratio was 2 to 3, okay? And the ratio was the boys to the girls, so it's going to be boys to girls, okay? And then they ask us, what was the total number of boys? Okay, so firstly what we need to do is we need to write the total number of equal parts. The total number of equal parts would be 2 plus 3, which is equals to 5, okay? So and then thereafter we need to say the number of boys is equals to 2 over 5. Why is it 2 over 5? Because 2 out of the 5 is the boys. Does that make sense? Okay, and then we need to multiply it by 25 over 1. The over 1 is because it is one group of grade 7 learners. So it's one group of grade 7 learners, but there are 25 learners, okay? And then it is 5 because it is the number of equal parts. So 5 because it's 2 plus 3. And out of the 5, we take 2, okay? And we just plot that, okay? So then what do? We say 2 times 25 is 50, and 5 times 1 is 5. 50 over 5 is 10. So there are 10 boys. Okay, so that is simple. That is straightforward. We just need to look at it step by step. Okay, then they say over here, calculate 10% of 1500 basically, or 1500. So what do we do here? We know that 10% is actually 10 over 100. So with that said, what do? We just say 1500 times 10 over 100. That will give us, so what do we do from here? We say 1500, we cross cancel. Actually, that's what we're gonna do. We're gonna cross cancel. So we're gonna say 15 times that is actually 15. So we're gonna say 1500 times 1 over 100 times 10. Okay, and that will give me 15 times 10. Okay, and my answer is 150. Okay, so then 10% of 1500 is indeed 150. Okay, so if we wrote it in terms of rands, we would say therefore our answer is 1 rand 50 cents. Okay. Okay, that is with regards to currency, with regards to ratios and percentages. Okay, we look at 2.5. 2.5 is saying John traveled by car at an average speed of 80 kilometers per hour for 4.5 hours. Calculate how far he traveled. Okay, so sadly I do not have any space over here, so I'm just gonna grab some paper and we can go ahead and we can look at this question in detail. Okay, so I've got some paper. Let me just grab some paper, and here we go. So we have the knowledge that the average speed is 80 kilometers per hour, right? And we know that they are traveling for 4.5 hours. Okay, how far did they travel? So we want the value in kilometers. Okay, so there is a very nice trick in terms of distance, time, and speed. Okay, we can literally say 80 kilometers in 1 hour, because the per stands for division. Okay, so 18 kilometers divided in an hour. Okay, so 80 kilometers in 1 whole hour. Okay, so we can rewrite that as 80 kilometers over 1 hour, and we want to get our final answer in kilometers, right? So what do we do? What do we need to do for us to get our final answer in kilometers? We need to cancel out the hours. Okay, so we need to cancel out the hours. So if we cancel these two out, the hours cancel out and we are just left with kilometers. So what we would get here is we would say then 80 kilometers per hour times 4.5 hours is equals to, so we just grab our calculator, we say 80 times 4.5, and that is 360. So we write that down, we say 360 kilometers, because these two would have cancelled each other out. So once we've done that, we say therefore John traveled a distance of 360 kilometers. Okay, and that is how you tackle this this question. Okay, just a few reminders that per stands for divided. So when we say per, we mean within. So within an hour, 80 kilometers was traveled. Okay, we want to cancel out the hours. So what do? We multiply by the hours that are given to us, and we want to get the kilometers, so we write our final answer in kilometers. Therefore, when we're done with everything, we write our final statement that John indeed traveled for 360 kilometers within those 4.5 hours. Okay, so that's how you tackle, this is how you tackle a question like that. And yeah, the emphasis is on the per of the sentence. So the per. So kilometers per hour. Okay. Okay, so then we move over to question 3. Okay, question 3.1.1 asks us to fill in the missing numbers in the following number sequence. So we have the number sequence 1, 4. What is the difference? It's plus 3. 4, 9 plus 5. We don't know. We don't know. We don't know. So as we can see, with the addition, what is happening here is that there's an incrementation of numbers. So from 1 to 4 is plus 3, from 4 to 9 is plus 5. But also there's also an incrementation of the differences, because the differences raise from 3 to 5. That tells us that there is a second difference, and that second difference is indeed 2, because 5 minus 3 is 2. So with that knowledge said, we can say 5 plus 2 is 7, right? 5 plus 2 is 7. Okay, so therefore the difference between these two needs to be 7. So then 9 plus 7 is 16. Okay, that's perfect. So we say 1, 4, 9, 16. So our first difference now between 9 and 16 is 7. So we say 7 plus 2 again, which is 9. 9 plus 16. Okay, so 7 plus 2. 2 is the second difference. So 7 plus 2 is 9. Okay, and 9 is in fact the difference between 25 and 16. Okay, so that's what we do as well. We say 9 plus 2 is 11. 11 needs to be the difference between 25 and the very last term. So what is 25 plus 11? 25 plus 11 is 36. Okay, so our sequence would be 1, 4, 9, 16, 25, and 36 at the end. Okay. Then we have the question, are the numbers in the above number sequence prime numbers, square numbers, or cubic numbers? So if we take a look at these numbers, we can see that nope, these numbers are not prime numbers, because 4 and 16 and 36 are not prime numbers. They are not prime numbers. Okay, and we take a look, we see, are they square numbers? 1 to the power of 2 is equals to 1. 2 to the power of 2 is equals to 4. 3 to the power of 3 is equals to 9. 4 to the power of 2 is equals to 16. So we can see that these are square numbers, because 1 squared is 1, 2 squared is 2, 3 squared is 9. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is indeed 36. So we can say, okay, yes, these are square numbers. So we can say these are square numbers. Okay, we can see that if this was a function, okay, the function would be x squared. Okay, why do I say that? Because we have values 1, 2, 3, 4, and 5. Okay, and if we square 1, we get 1. If we square 2, we get 4. If we square 3, we get 9. Square 4, we get 16. And we square 5, we get 25. Okay, so yes, indeed, they are square numbers. Okay, 3.3 says, study the following diagram pattern of a regular octagon and then complete the table. Okay, so the very first one shows the number of polygons. Okay, polygons are the shapes. Okay, and then it says number of sides. So the first polygon has 8 sides because it's an octagon, and octagons have 8 sides. And then the second, the number of polygons, so when there's 2 polygons, there are 15 sides. That's because the one side is being shared. Okay, the third one is 22 sides, because now there are 2 sides shared. So there's a long way in dealing with this question, but there is a far more shorter way with dealing with this question. Okay, we can notice that with each occurrence, okay, 1 times 8, that's 1. Okay, but when there is a moment where there is more than 1 polygon, then it is 2 times 8 minus 1. So in position 2, it's going to be the position minus 1. Okay, so then this is position 3, right? So then we say 3 times 8 minus 2. So it's always going to be this number minus 1. This number minus 1 is 2. Okay, so let's just check that for evidence sake. So 3 times 8 minus 2 is 22. Okay, so 3 times 8 minus 2 is 22. We do get 22. So we can apply the same knowledge with the fourth one. So we can say 4 times 8 minus 3, because they're going to be 3 shared sides. Over here, there are 2 shared sides. By shared sides, I mean these parts, okay? And here, there's only 1. So when there's 4, there will be 3 shared sides. So we can say 4 times 8 minus 3, and that will give us 29. Okay, we can look for if there's a common difference. Let's just check to see. 7, 22 minus 7. So yes, there is a common difference, which is indeed 7. Okay, and with that said, we can create our nth term, which is known as our general formula. We can say that our nth term is indeed 7n plus 1. Why is it 7n? Because we are multiplying the position. So we are multiplying the number of polygons. So 7n plus 1. Okay, so if we substitute 1 into the general formula, we will indeed get 8. Okay, and if we substitute 2, we will get 15. We substitute 3, we'll get 22. substitute 4, we'll get 29. So the general formula is kept by looking at the common difference, okay, between the output numbers. And once you've gotten the common difference, you can see whether you are adding it or whether you are multiplying it, and we go from there. Okay. Okay, so then when we look at 3.3, it says use the given rule to fill in the missing values in the following diagram below. Okay, so we have 7, 11, we have 3.3.2, we have 20, we have 11, and we have 3.3.1, 21, and we have 3.3.3. So firstly, what are we going to do? We're going to look at the relationship. The relationship is 2 times p minus 3. Okay, if we look at the rules of BODMAS, okay, BODMAS. So if we look at the rules of BODMAS, we need to start with the multiplication. So 2 times 7 is 14 minus 3 is 11. 11 times 2 is 22, so we're just going to write that down. 11 times 2 is 22 minus 3 will give me 19. Okay, will give me 19. So answer for 3.3.1 is 19. And then we look at the second one. What did we say? If we don't know the input, we replace it with a variable. So we'll just use the variable s. S times 2 minus 3 is equals to 21. Okay, what do? We say s times 2 equals 21 plus 3. Okay, then we say s is equals to 21 plus 3 over 2. 21 plus 3 is 24 over 2. 24 over 2 is 12. So our answer for the second one is 12. Okay, and then we look at the last one. And we say 20 times 2, or rather, let me not confuse anyone, 2 times 20 minus 3. Okay, 2 times 20 is 40 minus 3. 40 minus 3 is 37. So our answer would be 37 right over there. Okay, and that is simple. If you do not know your input value, you replace it with a variable, and then you solve for your variable. And if you do know your input value, then you just plot in your input value into the position of the variable to get your output value. Okay, then we look at 3.4. 3.4 says calculate the value of C3. Just gonna write that down, C3 plus 12. Okay, C3 plus 12 if C is equals to 3. So if C is equals to 3. Okay, so what do we do here? We say 3 times 3 times 3. Okay, plus 12. Because if C is equals to 3, then it would have been 3 cubed. Okay, so what do we do first? We look at the multiplication. 3 times 3. What is 3 times 3? 3 times 3 is 9 times 3 again plus 12. What is 9 times 3? 9 times 3 is 27. 27 plus 12. What is 27 plus 12? We put it underneath each other, and we get 7 plus 2 is 9, and 2 plus 1 is 3, and we get 39. Okay, Okay, we are asked to solve the equations by inspection in 3.5. Okay, so by inspection we are asked to solve for the equations. So basically by inspection, we in simple terms we are asked to just put the solution and not show extensive steps, but show that you understand and you know that k is equals to this or y is equals to this, because it is so non-complex. It is not that complicated. So by inspection we are asking you to just say, okay, k is equals to this, y is equals to that, z is equals to that, without an extensive procedure of you showing us step by step. So that is what by inspection means. It just means please don't show us any steps, or refrain from showing us so many steps. So this one is pretty simple. What we need to do is we need to carry over the 3 and we need to multiply 9 by 3 so that we can get the k alone. So we can simply say k is equals to 9 times 3, which is 27. So therefore k is equals to 27. Okay, it's not that hard, it's not that complicated, nor is it complex. The second question asks us y minus 17 is equals to 13. What do? We take this 17, we put it on the other side, and we actually say plus 17, because we know that if we plus 17 on the other side of on the y side of the equation, we know that minus 17 plus 17 is indeed 0. So we can add on both sides, or we can take it to the other side. So when we take it to the other side, when we take minus 17 to the other side of the equal sign, we get positive 17, and 13 plus 17 is y is equals to 13. So 13 plus 17 is indeed 13. Okay, that is just some quick math that you do in your head. Like I said before, no extensive calculations or anything of that sort. Okay, so we have 3.6.1. It says write an algebraic expression for the following. X increased by 5, so that is easy. We say x plus 5. Okay, that is all. When x increases by something, it is added. It's an addition. It's an addition statement. Okay. Write a number sentence for the following. Okay. 2 times a certain number p decreased by 8 is equal to 12. So first things first, we say 2 times a certain number p decreased by 8. What is decreased? 2 times p. Okay, is equal to 12. And if we write that in a simpler form, we get 2p minus 8 is equals to 12. Okay, and then we look at question 8. So what I did here is, in fact, I started with question 8 before I could go to question 7, which was a mistake on my side. But let's just take a look at question 8, and then we'll go to question 7. Okay, so question 8 says a mother is twice as old as her daughter. How old is the daughter if the mother is 64 4 years old. Okay, so the mother is twice as old as the daughter. So the daughter's age, we're just going to keep it as X. We're going to say daughter age. And then we'll say the mother, a mother is twice as old as her daughter. How old is the daughter if the mother is 64 years old? So the mother is 64. Okay, is the mother. And we are asked to find the daughter's age. So the daughter's age is divided by, is the mother's age divided by 2. Okay, and the mother's age is 64 divided by 2. 64 divided by 2 is 32. So the daughter is indeed 32 years old. Another way of looking at it, we would have said the mother is 2 times the daughter's age. So we could have said mother is 2 times the daughter's age. So 64 is equals to 2x. And solve for x, and we would get 64 divided by 2 is equals to x, and we would get our daughter's age. Okay, the product of 2 prime numbers is 10. Okay, what is the difference between the 2 prime numbers? So the product of the 2 prime numbers is 10. What is the difference between 2 prime numbers? So first things first, what we need to look at first is the factors of 10. So 10, okay, so we have 1, we have 2, we have 5, we have 10. Okay, that was quick and simple. One is a prime number. Okay, 2 is a prime number, 5 is a prime number, 10 is not a prime number. So we can see here that the 2 prime numbers that will be involved are indeed 2 and 5. Why is that? Because the product that is formed is 2 and 5 is 10, and 2 and 5 multiplied to each other give the solution 10. So we can write 5 times 2 is 10, right? So those are the 2 prime numbers that we have that we've distinguished. So what is the difference between these 2 prime numbers? 5 minus 2 is indeed 3. Okay, that was a simple way to tackle things. Okay, then question 7. Okay, sorry about that once again. Question 7 says calculate the parameter of the rectangle if the length is 11, the breadth is 5. Okay, so first things first, we need to think of the parameter equation when we're finding the parameter of each shape. So the parameter of a rectangle is 2L plus 2B, okay, where L stands for length and B stands for breadth. Okay, right. So with this said, we can simply just plug in the values that we were given and find our parameter. So we say 2 times the length is 11 centimeters, plus 2 times the breadth is 5 centimeters. So we have 22 centimeters, plus 10 centimeters. 22 plus 10 is 32 centimeters. Okay, as we know, a rectangle looks like this. Okay, this two lengths and 2 breadths, and that is why the parameter is 2 lengths, is 2 length plus 2 breadth, because we're trying to find the whole area in which it covers. Okay, by it I mean the rectangle, so by the whole area the rectangle covers. Okay, 7.2 says write down the formula for the surface area of a cube. Okay, so that is study work. We know that a cube has the surface area of 6l squared. Okay, I'm just gonna say surface area. Okay, a cube is as follows. This is how a cube looks. A cube of dice, a cube of ice. Basically it is that. Okay. Yes. So our surface area formula is always 6 times the length squared. Okay, then our final answer for this video, our final question for this video is in the rectangle prism below, so this one over here, the length is equals to 5 centimeters. Let me actually write this on the other side. The length is 5 centimeters. Okay, the breadth is 3 centimeters, and the height is 10 centimeters. Okay, length 5 centimeters, breadth 3 centimeters, and height 10 centimeters. Okay, and we are asked to calculate the volume of the rectangular prism. We know that with prisms, with rectangular prisms, the volume formula is length times breadth times height. Okay, to give me length is 5 centimeters times breadth, which is 3 centimeters, times height, which is 10 centimeters. Okay, 5 times 3 is 15 centimeters squared. 10 times 10 centimeters. Why did I square it? Because I'm timesing the unit of measurements as well. Okay, and then 15 times 10 is 150. 150 centimeter squared times centimeter is centimeter cubed. So that's how we get our unit of measurement in terms of area, in terms of volume. We multiply the units of measurements as well. So our final answer would be 150 centimeters cubed. Thank you for tuning into this video. I hope these examples will aid you in understanding the different concepts of mathematics and the different tricks into how to tackle different questions. Okay, thank you once again for tuning in. I hope to see you in the next video.